Hello and welcome to Module 2, Part 2, and we're going to start talking about energy mechanics, specifically Newton's laws of motion. So here we go. Newton's laws of motion, we're going to talk about the three major laws of motion, the law of inertia, the law of force is equal to the mass times its acceleration, and the law of action and reaction, so the reactionary forces. Isaac Newton is one of the great minds of physics. And so here's just a little bit on him because, got to pay a little tribute. The laws of motion, here's the quick write-up of each one. So every object in a state of uniform motion tends to stay or remain in a state of motion unless acted on an external force. If you were taught this first law in the other direction, where it's in a state of rest, do not say it that way. That's inaccurate. Actually, the force acting on everything on our planet is gravity holding it in place. So there is something acting on it. It's the other way around. It's that it will continue in motion unless something says otherwise. Second law, that there is an equal force that has its mass times its acceleration. And then finally, the third law, every action has an equal and opposite reactionary force. First law is known as the law of inertia, which basically everything will be in motion. Once again, if you learned it in the other direction, we're at rest. On our planet with gravity, everything is being held down by gravity, so there is a reactionary force upon it that is forcing it into place. If you exceed past that force, you can move against it, and hence throwing a ball up in the air, right? So you're exceeding the actions of gravity upon that ball to make it go up. Eventually, it loses some of its inertia, and gravity drags it back down. So, that does mean that without something to stop it, you will continue in motion. And one of the great examples, of course, is the old trick of pulling the tablecloth out from under the plates, that they're going to be held down by the actionary force of gravity to the actual table. And so you'll be able to pull the tablecloth and have everything else stay in place. And this trick actually does work if you pull downwards on the tablecloth. So just pull down and you'll get it to work. We've already talked about why do things stay in place, and that's gravity. That's the number one reactionary piece. But one of the other major forces is frictional force. And frictional force can be broken down into four categories of frictional force, of how it's going to act. And a lot of times an object will have multiple frictional forces acting upon them, but the categories that you can think of is sliding friction, so like ice skating, when you're sliding across the ice. Rolling friction, you can think of things like bowling, where it's falling over itself. Fluid friction, we're living in that every time you walk across the room or tilt your head, or me moving my hands, the atmosphere, I'm moving through the atmosphere, which is a fluid. So I'm creating a fluid friction or resistance in the material that I'm working through. And static friction, which is the initial friction when moving an object. So when something has been in situ in place and you begin to get it to move into a sliding or a rolling motion. You think of pulling a big bira before you get it started, and then finally, so you have your static friction for a moment, and then you get it to slide. The next law, the second law, is force is equal to mass times acceleration. There is a relationship between the mass of an object and its acceleration, which is applied or equal to a force that is of that object. If I change its mass, I will change its force. If I change its acceleration, I will change its force. And so I need to put these two things together to get a final force on said object. Therefore, heavier objects require more force to accelerate, right? There is some simple units that go into this, and when you're playing with force, you're going to be using newtons. until further in the course, and then I'll introduce you to some of the English systems for force, which are a bit funky, but you should know a little bit about them, especially if you're going to work in the industry of alternative energies, because you're going to use a lot of funky English system measurements as opposed to the System International, the Newtonian systems of measurements. So 1 Newton is equal to the meter divided by seconds squared, so over time. And that is times a kilogram, so it's mass. So you got mass and acceleration. And simple formula, everything written out for you in an example. I'm going to keep clicking through because you can basically take your time and look at the slides at your convenience. Little bit of check your understanding. If you would like to practice just working on flipping back and forth, I know the math is easy. I get that the math is easy, but I would like you to be able to flip back and forth between being able to do this really simple math and just getting the units. So it's really more about making sure that you end with the proper units than the number, because I know that you guys can do things like divide 12 by 3. I understand that that's within the wheelhouse of capability. It's that when you divide the 12 newtons by the 3 kilograms, you're going to also understand that a newton is the unit of kilograms, meters, divided by seconds squared. So you know that your unit that's left over is meters seconds squared for question 1. So here is the answer key. Once again, just keep track of your units. Which brings me to the 3rd law. For every action, there is an equal and opposite reaction. We can think of things like jet propulsion, where we are pushing off of the atmosphere, and as the rocket takes off into the atmosphere, it pushes down on the actual exhaust coming out, and the exhaust pushes back up on the rocket, accelerating it forward. So equal and opposite reactionary forces. Another way that we can think of it is air buoyancy. Air buoyancy is important because it helps us understand how something can exceed or move upwards in lieu of gravity's force pulling it down. And so it's a very important sort of thing to keep in mind, and we'll talk more about it a little bit when we talk about fossil fuels and pollutions and a little bit along those lines, as well as other components that'll have things that will exceed the force of gravity or work against the force of gravity. There's a lot of examples of Newton's 3rd law in nature. You think of a fish. The fish pushes with its fins back at the water, and the water pushes back on the fins, pushing the fish forward. Same thing with a bird. The bird pushes down with its wings, and the atmosphere pushes back on the wings, pushing the bird up, giving it lift. And so there's a lot of examples of 3rd law in nature. One of the things to keep in mind is that every actionary force has a reactionary force, and so it can move against you. Think of people who are runners. If you run a lot, your body, your legs, your knees, your joints take the pounding of the reactionary force, because every time you step down on the earth is acting back up on your legs and knees and joints, which could eventually lead to deterioration or injury. So you can always have these opposite reactionary force. Or for example, that little fly that hits a windshield, right? Your car is moving forward at its accelerated pace of 65 miles per hour, and that poor little fly hits your car windshield at 65 miles per hour. Now both of you have that force acting on you. That little fly has a force that is hitting the windshield, right? But it only has so much mass, where the car is so massive and its force is hitting back at the fly at 65 miles per hour. And the reactions are different. The windshield has barely anything. If I was looking at an atomic level, I would see a little ripple, but otherwise than that, there's nothing. Where that poor little fly explodes all over the windshield because it can't handle that heavy force of the mass vehicle, while they both were hitting each other with equal and opposite reactions. So that's a little bit on Newton's law, and I will meet you back for part 3 of our videos on the module 2.